Now, I haven't done any tinkering with unit tests, but one of the ways that image mode is kind of cool is, we build that image. It's a bootable container image, right? Well, how can I test that image without deploying it to a machine? And it's actually really cool. You can just run it inside of Podman or Docker. So remember we said it's an OCI compliant container image. So I'm going to do a Podman run. We're going to run it interactively. We're going to tell it to remove it when it's done. That's what the -rm is for. And then we're just going to point it at my RHEL 9 image mode hypervisor image. Now, this will be the one I built before tmux because that job was still running. But if I run this, what it should do, I already have the image pulled down. I did it before the show because it's like 1.5 gigs or something. But I'm now running it within Podman. Now that looked a whole lot like a machine booting up. That's because it runs full init, full systemd within this bootable container image. Because it's a bootable container. It's meant to be a full image. You'll see that some services failed. A lot of these are things that you might expect to fail because it doesn't have a full kernel and a full booted system to work with inside of the container. So those are things you won't be able to test inside of the container. But did my files get copied in? Is the web application tree intact inside of the container? Does the Apache service start up, right? Those are all things that I could easily test from within here.
Yeah, and we are working on tools too within Podman Desktop and also, I'm not sure the status of the actual Podman CLI, but being able to spin up a virtual machine quickly without having to build the image, launch it, build a QCOW, and like import it, which is what I do on a regular basis. It takes a little while. We're looking at ways to be able to run it this way so you can do that quick test and then also like spin up a virtual machine really quickly with Podman machine.
Yeah.
So that way you can do more like I really need to test that this kernel patch applied or something along those lines or a kernel argument. That's it. So we're looking at ways to make sure that you can do those sorts of things locally, right? So you get that full local development and testing environment without too much effort.
So the one thing I do want to learn next is how to do unit tests against the Bootc containers or unit tests against containers in general. Because like I said, I'm not a developer. I've got very little experience with all of this. And I would love to figure out for those handful of containers that I manage, right? Like when I do that build, I want to make sure the thing works so that when I try to deploy it to my things, I'm not deploying a broken container.
Yeah, you and me both.
Right. That's the next thing to figure out.
Yeah.
Okay. So that was essentially what I wanted to show. We're at 12:59. You still had something to talk about with tags. Do you want to cover that quick or is that going to take too long?
Well, we can do it quick.
Cool.
I think there's one other thing though that I want to show in order to talk about something that's in comments about grub2 and boot containers and these sorts of things. It's something that I harp on maybe a little too much. If you want to flip back to my screen share, this is out of our official like technology decks. You might see this if somebody comes to a road show.
Is this a slide, Matt?
It is a slide, but it's an important slide.
You broke the rules.
I know the rules, but this is like my pet peeve that we really don't explain well, and I want to make sure.
Okay.
We talk about all this stuff being in containers and containerized. Containers are just the transport and build mechanism. What is happening on the system is not in any way, shape, or form anything you would normally suspect or expect with a container. What is inside the base image we publish is relatively, in the terms of what people think about in containers, it's massive, right? These images are 1.5 gigs. It has a kernel, it has systemd, it has grub, it has firmware, it has network manager, it has all sorts of things you never need to put in a container to run an application because they're not containers in that sense, right? That's why I talk about them as Bootc images and not container images, is because these are full RHEL hosts. Mm-hmm. I just want to make sure that the question in chat was about, do we add grub2 to containers? No, this is a fully specialized minimal RHEL system.
It's a disk image.
Useful, but it's bootable right now. You could just grab our base image and boot it. You can't do a lot because it's like
you would. I think you would make these more akin to an image that just came out of Image Builder, except it's built to run in a different way, right?
Yes.
So Image Builder spits out a bootable virtual machine. It's a disk image that's a full operating system. That's essentially what you're dealing with here, except it's packaged up differently and it's made to be deployed differently.
Exactly. So yeah, if you think about our KB images or something that you built out of image builder. That's what we're talking about. We're not talking about UBI that you throw grub into and expect to work. Like it's a lot more complicated than that.
Right.
Cool. So this was our published image, right? So it published an hour ago. So one of the things right on tags, so these are tags that we added during the build. So GitHub adds these, and you can see, we still have some other things that Quay is warning us about our security stance. But the thing to know about images that I want to get across when we were talking about it earlier with like, do you use specific tags or other tags? Tags are just metadata. They come from the people who add them during build systems. So you'll see this little line over here. This is this SHA manifest is what, like if you really want to be like very specific, the application folks tell you to use the SHA because you can tack whatever label you want on things. So it's all about what you want to do and how you manage your tags, right? One of the things you can do, and this is in my mind, right, is you could use this to your advantage to say, we have dev things, we have test things, and we have prod things. The way that you control visibility across all of your environments is simply take a tag and say, we're going to add dev onto this because this is our last build. It's not ready for prod. We could tag it to dev, and then only the development machines tracking CI demo dev would see it. If they're tracking test or prod, they would never even know there was something available to be updated to. So not only does that give you lifecycle environments for packages, it also means you're not rebuilding things lifecycle environment using the same starting point. You are literally using this image that you validated through your testing and saying this particular image is known good. It should now move along. Literally are moving the same binary artifacts.
Think about that in a package mode world. You've got a server, it's out there, it's in the wild, it's doing its thing, and it works great. Now it's patch day. You install patches, and they install the way they install, and that's pretty predictable. But what has happened to that machine since the day it was built to the day that you're installing those packages? There's so many things that I've seen go wrong in that time frame. What if you hadn't been updating this machine? I know that's bad practice, but what if it's been a year since you've applied updates to it? And in the meantime, certificates changed or something. Now all of a sudden DNF is like, I can't talk to the repo because it doesn't have the certificates that it needs. Now, there's ways to fix that. But at 2 a.m, when you're updating that production system, you don't want to have to think about that. You want to get the job done, make sure it works, and make sure that it's ready for production so you can go back to bed, right? Also, here's another great use case, and this is like tinfoil hat, right? Say there is an undetected compromise on that machine. And this is one of the beauties of containers too, right? When you do a Bootc upgrade, it's eradicating the entire immutable tree, right? I shouldn't say eradicating, it's replacing, right? And there's a good chance that undetected vulnerability or undetected compromise just got overwritten. And you reboot the machine, and now it's gone. You may have never even known it was compromised. If you did know it was compromised, re-image it, and up it comes without the compromise. Now, that's not foolproof. Don't get me wrong. I'm not saying this is the solution to all of our compromise woes. But it's exactly the deal with a container. Someone breaks out of the service running in your container, and they do nasty things to your container. You just nuke it and build a new one. Well, now you can do it with actual RHEL hosts, which I think is pretty cool. Sorry, I went on a tangent.
Yeah, no, it's perfectly fine. But yeah, and this also gets back to that conversation about do you DNF update in your container build or not? Like, well, this is part of it.
Right.
How much control and how much when you know, like, now the good thing is like if you're using a RHEL, because in personal practice on my laptop, I use just the containerized registry that has no interface. But things like Quay will have security scanners. If you've got other security scanners for container tools, it will actually tell you, like we mentioned, right, containers are just tarballs with fancy metadata. Well, these manifests, right, you can actually see all of the stuff that's in there. So there's other ways to track like where packages are and what's been going on in the image build. Right. It's not that it's completely invisible. It's just a matter of where you need to see it and how you want to dig for it. These are all things that, you know, either we have wired up other places, so we're not losing, right? We're not going to lose security scanning because we move to containers. We can now do it in multiple places. We can get it at image level and then at host level, because you can still run your Nessus scan. or CrowdStrike or whatever else on the actual host, right? We're now getting back to your suspenders. We got belt suspenders and rivets that we're now putting on things to make sure stuff doesn't fall down.